right, Wasm't.io, great to see everybody today. Let's go ahead and get started with I wasn't expecting this many apps, scaling without losing your bytes. I'm Randall, CEO and founder of Cosmonic, co-creator CNC of WasmCloud, and I've got a long history in building open source companies. I built companies around Kubernetes as the first entrepreneur in 2014, Bro, Zeek, OS Query, and lots more.
My name is Bailey Hayes. I'm the CTO at Cosmonic. I also serve as the WASI co-chair and at-large director for the Bytecode Alliance Foundation.
Great. Today we're going to spend a little bit of time talking about platform engineering, which I think is one of the most incredible use cases for WebAssembly. And we're seeing incredible adoption across CNCF WasmCloud. But we're going to start with a quick look backwards. How did it get so bad? Then we're going to review the state of the world. WebAssembly is not the only game in town, and there's lots of teams that are working hard to solve this problem. We're going to review the state of the world, the platform harness pattern, introduce a reference application that looks an awful lot like what our customers look like, and then talk about harnessing some of the superpowers and security, and then finally end up reviewing real-world adopters of WebAssembly for platform engineering. But let's start with the original sin of platform engineering. Why is it so bad today? It really comes down to the way that platform engineering teams build and operate their companies. Like a lot of original sins, it starts with something good, a good idea. Let's give the developers a checklist that solves all of their enterprise to-dos out of the box. Unfortunately, what happens is, as developers start to copy these templates, whether they're in Java with Spring Boot or in Go or another language, there is drift from the original template. They struggle to keep their isolated dependencies up to date, often taking divergent and incompatible paths. And ultimately, they end up tightly coupled to the capabilities that exist in a given platform. Now, these platforms are disparate and spread across the previous epochs of tech, whether it's on VMware Broadcom, early forays into public cloud, or on your own edge. They're fundamentally incompatible with each other and isolated today. Now, we've been building CNCF WasmCloud with platform engineering in mind since day one. It was based on my experience working at a large Fortune 100 in the United States and the terrible realization that we'd created the world's worst problem, where we asked 5,000 developers to fix one vulnerability one time, instead of what we really wanted, which was a world where one team could fix 5,000 vulnerabilities at once. And our model absolutely revolves around WebAssembly components. With WebAssembly components, we're able to pull them together into golden harnesses that platform engineering teams can keep up to date, migrate, share across languages, and ultimately, as you'll see in our real-world use cases, take across disparate execution planes, oftentimes operating in different planes at once. But what about the previous epochs of tech? What about other companies and organizations that are working to solve this problem today? Regardless of where your organization or company may be now, we do see this continued abstraction where we're continuing to isolate developer code into the smallest and smallest microsegment. Bailey, I think you're going to give us a quick tour of some of the other ideas that are out there.
Yeah, so locally right now, I have a kind Kubernetes cluster running. I'm trying out some of the state-of-the-art, so I worked through Knative's Quick Start, and I was really impressed with what I found. So I'm able to say, OK, I've got Go, and I've got a Node.js Knative function deployed. I'm using what they call Knative serving, so I'm going to be able to request through HTTP to the service. If you want to see just kind of like what it looks like to have the full stack, I've got I did their lightweight courier for my API gateway, and I'm using their eventing and serving controllers to do this deployment. So let's call my Node.js Knative function. And what you saw there was a little bit of a pause, right? And this is when we talk about how WebAssembly components themselves solve the cold start problem. I saw a cold start, but let's measure that. So I've got this command here for asking curl to give me a little bit more information on my request. So the past request, I did it to the Node.js container. This time, I'm going to do it against Go. And so we see 1.4 seconds. Now, that typically won't meet the SLOs of large enterprises. They almost always have something around 300 milliseconds or less, because that's the attention span of anybody using the internet today. And so this is why a lot of folks aren't able to scale their containers down to 0. It's fairly large. Now, if I look at the resources being used, though, sometimes people talk about how large containers are, but check out these. These are itty-bitty. There is so much that's happened over the past decade in containerization to make our containers much smaller, best practices to make them more secure. There's just a giant ecosystem out there. And so I think it's really important for us to highlight that we're not talking about completely replacing containers. There's a lot of places where they're very powerful. But there's a key weakness here that's inherent into the properties of just building a project with containers. So my little example here is just a simple HTTP handler. It doesn't do any work. It just prints out once it's gotten it, decodes a body, and then returns. It validates the body of the response, but doesn't actually call in and do any other work. What I did is I deployed it, and I tried to create 100 of those. I'm not going to do that live here, but I took screenshots of it, and once you start running about 50, I started seeing degradation in my response times. My gateway was too lightweight to be able to handle this load. Once I got over 100, you're probably familiar with pod limits that are in Kubernetes. So for me to be able to run this many functions, I need to be able to scale out my infrastructure effectively. So that's not something that you would ever want to run on a MacBook. So obviously not super scientific here, but you would be able to run this on any other larger infrastructure and witness basically the exact same thing. So jumping back to our slides here, if you crack open the two apps that I was looking at, I'm using a tool called Dive. Again, it's very efficient. Right now, its efficiency score is 97%. So they've got a quick start that takes you on the path to doing some of the best practices with containers. Although you'll see on the right-hand side that I'm bringing over a lot of different system libraries that comes inside a container, which, again, inherent to containers. It's virtualizing an operating system. And I needed that to be able to run Node.js, to be able to run my function. So this is what I've packaged up in that container. For the Go one, kudos to them. This is 16 megabytes. This last one was 141 megabytes. And again, for containers, incredibly small, very impressive. But when I tried to run this at a scale of about 100, I maxed out my memory, maxed out my CPU. It's just not really meant to run hundreds of these without scaling out your infrastructure significantly. So you might be thinking, who would write 100 microservices, 100 functions? But just about all the customers that build with us today, we're usually seeing thousands of application developers building thousands of apps. And it's not just about running a single cluster in US East 1, it's about running in every region and zone globally. So this problem is magnified for those users. And that's where I think it's important to highlight that there's this incredible amount of waste because of the nature of building with containers. And there's this great State of the Cloud report from Datadog that points out 80% of our platform costs today are wasted. A big part of that just comes from the long cold starts, right? If I have to have my container already running to be able to service the request when it comes in, then I have to always just have it up, and it's sitting there idle. And now, it's nice that I just have to have one, and I can elastically scale that one out. But regardless, it's just sitting there idle, so I need to make sure, basically, that the service is frequently being run. Another aspect there is I showed what was inside that container. Now that was an awesome container, like best practice of that's out there. a lot of people aren't building containers that look like that. And so when you crack open other people's containers, maybe they've got like all of Debian, and they didn't do Alpine, or they didn't do Distroless, or UBI, or one of the chain guard images. And so just the resource density problem here gets magnified. And we showed that by just simply running 100 functions is not something that's very easy to run on a simple local kind cluster. And all of this combined leads to costly idle infrastructure. And last but not least, we still haven't even talked about security in containers. I'm just kind of like dodging that for a second, but I think we've all kind of understand that containers themselves aren't secure by default. There's been plenty of different types of exploits that happen, but that's one of the key aspects when you compare WebAssembly components with containers. It's really important to do a dive on the security story of components. So what does the future look like? Well, hey, we're here at Wasm.io, so you know what I'm going to do. I'm going to sprinkle some Wasm on it. This is an example application architecture. We call it WasmPay. This is something that looks a lot like a lot of the customers that are deploying on us. Now, this is it's got a lot going on, and so I'm really only today going to zoom in on this one key piece. So the idea of WasmPay as a reference architecture is that there are going to be many different banks that are doing bank-to-bank transactions, and due to their regulatory requirements, they need to be able to write validators that say, hey, this payload is valid, please run this transaction. There's easily like hundreds of these that need to be executed, and it's different per tenant, different per bank. And so each one of them needs to be able to run on top of the WasmPay platform to be able to execute. And so in this case, we're going to zoom in on just the platform harness. This is the new architectural pattern that we've really seen emerge that's incredibly powerful that you can do with WebAssembly components. And here you can see that it's in between the rest of the system. So everything that goes into that bank validator, first it comes in with our platform harness. So I've already been doing comparisons with containers, obviously. So if you're familiar with the sidecar pattern, you can think of it as something very, very similar to that. Now, the next part here is our tenant developer component. We are able to run with essentially thousands of these different validator functions on the exact same host safely because these components are isolated from each other.
That's a great point, Bailey. What we're really servicing here is a group of developers that are oftentimes first party, but still need isolation, or sometimes even third party across companies or across organizations. So absolutely zero trust between them across their boundaries.
Yeah, so let's like dive into a little bit of the code there. This validator, it's called Nordhaven, written in Rust. I bring in my bindgen. Now, I'm not really doing any type of real workload here. Again, reference architecture, not meant to be a real platform, although if somebody wanted to make WasmPay, talk to me, I would totally support you. But here, we're just checking to see if you're transacting with the Nordhaven bank, then the only type of currency that you're able to use is USD. Now, maybe in the current climate, most people are trying to get off the USD, but I didn't write this part of the demo. Next step. We have the platform harness. So this is the second component that gets built. It's got its own world that it's targeting. And the thing that I wanted to highlight here is that the way that messages come in, like executing and validating a transaction, first it gets the request, and then it calls the component's validation handler, and then returns that request. So let's give it a little bit of a run through. Let me bring this up. And I'm going to make a simple curl call. So I'm transacting. Bank 1 is saying, hey, I want to make a transaction. Bank 2 is like, hey, yeah, here's the currency. This is what I need to do. Transaction's approved. If I pass in an invalid transaction, in this case, I'm making a request saying that this other bank wants to transact with yen. And we already saw Nordhaven doesn't know how to interact with yen, so that validation fails. So that part is fairly simple, kind of straightforward. But let's run a scale test of this. So this I had to pre-populate, mainly because I decided to see how much I could run. I got up to 10,000, but then while I was out there, my battery just started draining so fast. So thank you, Ralph, for letting me steal Microsoft's booth's power outlet. That was very helpful. And so I'm successfully able to run 10,000 functions that are unique with a different ID right here on one single host, also running on my laptop. And so that's sort of the basic idea, is that we want to be able to say, our developers, our tenant developers, right, these banks, are able to code to this single interface. And when you code to this single interface, you probably heard Luke Wagner talk earlier about SDKs for free. So Wasm't, it loves being able to build with these interfaces because they can generate SDKs for all of the different languages of all their different tenant developers and what they want to run on top of the Wasm't platform. And so the interface that they're building against kind of looks like this. So this is a thing that developers might see, although they might just be interacting with an SDK and they never see WIT at all. That's totally possible. But what the machine sees is the WIT on the right. So on the right, we see the kind of the rendered WIT of the full component once we've built just the tenant developers component. It's got things for WASI, so hey, I want to interact with maybe a file system, but most importantly is this export here at the bottom. I know how to transact validations, so call this when you want to execute me. Now, let's take a look at the platform harness. The platform harness WIT looks basically like this. It's got a pass-through for doing the validation handling. It also has these triggers that allow it to work off of a message bus or over HTTP. And so when we compose these two components together, out comes a WIT that basically looks like this. So this component is able to interact with the outside world, whereas my previous tenant developers component, it actually didn't have access to HTTP, it didn't have access to a message bus or anything to actually interact with it. And that gives us many different types of superpowers. From being able to do virtual platform layering, like Dan is going to talk about tomorrow. We could do real-time traffic shaping. Again, if you're familiar with sidecar patterns and containers, all of that same stuff basically applies. And again, SDKs for free. So Wasm't platform provides many different SDKs that just work seamlessly, that they're able to maintain.
I want to come back here and maybe emphasize a quick point here. When we're down in the platform harness, you can see this is where we're bringing in HTTP. Because the platform harness actually brings a number of hidden dividends to our customers. One of the biggest of which is if we suddenly need to trigger our functions or our business logic on a different interface besides HTTP, we get that for free. We can simply update the platform harness and bring in triggers for key value, for messaging, for SQS, or other sorts of triggers that you may popularly see. Another key lesson that we've learned here is that in designing these systems to be successful, oftentimes it's not about what you bring with you. The most important lesson is what you leave behind. One of our community members, a large US bank, was on stage at KubeCon US, and they said something very profound. They said, our developers don't even know that they're using Wasm. And if we continue to do a good job, nobody ever has to really understand it outside of this room as well. Those have been very profound lessons that we take into every engagement, every interaction with our customers when we help them to design these systems for scaling globally. But Bailey was talking a little bit about some of the platform harness superpowers that we get. And when we were going back and forth around which of the superpowers we wanted to debate and understanding how many incredible speakers there were here this weekend, we thought we'd do maybe a deep dive on some examples in security. Security vulnerabilities come in a variety of different forms. Whether it's a simple exploit in C, like we have here, we essentially have an unchecked input sanitization vulnerability. This would lead to something simple like a directory traversal, or I could do a quick mock-up of what we saw with log4j, which is this is a simple web shell that takes what you send in on the URL and then turns around and just execs it on the local system. Now, we've all seen code this bad, and sadly, some of us have actually written code this bad. Maybe not you, Dan, wherever you are, but most of us have. But it leads to crazy things like this. And while the power of WebAssembly components and capability-driven security allow us to limit a lot of this, What about these rare cases that we've seen where developers do need to be doing the pointy thing or the thing that we're concerned about? And what we've found is that I think one of the most devastating things that we need to leave behind with containers is this ability for horizontal and vertical escalation across the attack surface you're bringing with you. I'm an old school security person, and I sometimes like to think of WASI almost as a type of extendable POSIX for the system. And when I teach this or explain it to my security friends, it makes sense for them because what I'm acknowledging is that with WebAssembly, we're able to embrace this principle of least privilege and not bring along all of these extra attack surface that can be used for pivoting out to other systems. So to summarize what Bailey showed you maybe in cartoon graphics before, what we're doing is we're taking these platform harnesses where we hide a lot of the complexity. Here in the complexity, we might be hiding device drivers. We might be hiding database implementations. Oftentimes, we're bringing in custom business contracts that are implemented as WebAssembly components that are part of that long extendable tail of POSIX, or however you want to think about it in your own mind. We give the developers the tiniest little interface that we want to give them, but what about these cases where still that's not enough, where, for example, in that C program, they need to open a file. So a huge shout out to Guy Bedford with WASI-Virt. A year ago, I think we gave a demonstration where we were overloading environment variables in an example, but we thought today we would demonstrate how easy it is to do that for file system access. Thinking about giving each and every component its own virtual file system, whether that's for scratch storage or for temporary analysis, or because you're trying to support some pre-existing function or code that you're bringing into the ecosystem. It works just like you've seen before, where we essentially have a harness and we're able to virtualize specific functions here, and then produce a new composed component here. So on our C example, the part that we're really concerned about here is this open file path. And where we see that in the code, if we compile this right to WebAssembly, is here in the file system pre-opens. And what this is Bailey, this is not a file handle, it's a
descriptor, yeah. So in WASI file system, well, actually the philosophy behind all of WASI is that it provides the ability to do capability-driven security. So in this case, when you're importing from an interface, and a lot of, basically all of them, you're importing a capability. So in this style, a pre-open's kind of a weird word, and we do kind of want to change it. And if you want to know some cool ideas on how to change it, check out Dan Goman's blog post. It's sunfishcode.blog. But here, with the pre-open, what we're basically saying is, hey, I've pre-granted access to these descriptors. And those descriptors can be files, and they can also be directories. In this case, it's actually directories. And so if we run WASI-Virt, we basically, with this command, what Liam did when he built this demo is he mounted a local folder called virtfs, renamed that to say, hey, virtually, aka in memory, inside the component adapter that we build, we want it to have at /virtdir. And then we allowed certain capabilities, aka granted these WASI interfaces to be allowed to pass through. And so out comes, after you run this, a composed component that no longer, and you might think like maybe I messed up my slides here, but this is intentional. I just wanted this to be empty because look, the file system pre-open capability is no longer granted. So when this component runs, it can't get access to any kind of file system, but it has it in memory. And so this example is executing that command and then running against wasm time, where it prints out the contents of that file.
Now, a lot of WebAssembly for the last few years has been the hope of what may come. And what I'm most excited to share today is some pointers for maybe some homework for people that are interested in learning how others are being successful in adopting these techniques today. So we've pulled together a couple of our favorite real-world examples that organizations and customers have published and shared out on the web themselves. The first is in the previous KubeCon, we saw American Express come out and give an incredibly detailed lecture about why they've adopted CNCF wasmCloud, and how they're using it for platform engineering. And they are incredibly well aligned to that platform engineering harness that we just walked you through. And if you review that talk, there is a gold mine of details that they share in their vision and why they see the world that way that I hope can inspire all of us to help continue to build better together with WebAssembly. What I love about working in open source is even just yesterday, or earlier today, I found out about a community member that's building automotive stuff in CNCF wasmCloud. It was nice to meet you. Say hello in Slack sometime. I didn't even know you were in our ecosystem, never mind for the last 18 months. Here's another example. The Norwegian Food Safety Agency recently open sourced their platform, which is a slightly different approach to platform engineering, but it still embraces the same tenets of what can we leave behind for our developers. How do we give our developer communities and our developer teams the smallest possible surface to interact with? How can we hide the details of those implementations behind WebAssembly components? What's really powerful about their use case is that it almost comes off as a sort of WASM flare approach. Embedded into CNCF wasmCloud, they've added a number of new capabilities for key value, as well as CQRS for event sourcing, so that their developers can spin up and run everywhere they can. And they've just updated their Terraform module because they actually executed on Google Cloud Run across distributed regions. We're working on a case study with them, and they've been a phenomenal set of community members that are helping to continue to build out the wasmCloud ecosystem. And then across the telco network, we've seen this project just hit 1 million downloads, which kind of blows my mind. And then I think about the scale of the telco world. And this is the TM Forum telecommunications group. They've done some standardized WebAssembly components to solve community problems. And oftentimes, what these customers are the most proud of isn't what they've built in wasmCloud. Here, it's a little hard to read the infographic on the left, but the green is all the developers have to worry about today with WebAssembly component composition. When developers want to communicate now, they no longer think about setting up web servers, setting up gRPC, mapping protocols back and forth. They simply think about interfaces, imports, and exports. And what becomes most important, and I think is the theme that runs across all of these organizations, regardless of what industry they're solving or where they're working, is that they've all embraced the principle of least privilege. They've all embraced the principles of least amount of code for their developers. And they're all thinking about how they can build platforms that scale on any cloud or any edge, including their own with CNCF wasmCloud. Thank you for your time today. I think we might have a minute or two for questions. Repeat the question if we get any. Okay. Sorry. That was supposed to be quiet. I said the quiet part out loud. Thinking out loud is talking.
Any questions?
We were so good, nobody had any questions.
It's easy.
That was great. There you go. High five.
Yeah.
No?
Yeah? Okay, fine.
All right. Okay, no questions. We're around all week, and we'll be at KubeCon next week. If you wanted to see what we're doing commercially or talk about platforms for platform engineering, we'll be in London all next week. We'll see you guys around. Have a great week. Thank you, Wasm't. Thank you, Barcelona.